So in this lesson, you'll be looking at something called constant rate of change. And you just saw a great example of constant rate of change when you watch the bus go across the kitchen floor. And because you have two different things going on, time was passing and then the distance that the bus had traveled was also changing. And what was happening was the distance was dependent upon the time. And that's exactly what constant rate of change is. It's where you have one quantity that depends on another quantity, or where one quantity is changing in reaction to another. So with the bus, its distance was changing in response to time passing. And that's a great example of constant rate of change. Welcome to lesson 3-7. In Unit 3, Lesson 7, we're looking at something called constant rate of change. We've already visited this idea a little bit when we talked about proportional versus non-proportional. When we're talking about constant rate of change, what we mean is how does one quantity change in response to another? And specifically in math, we're talking about how your y values change in response to your x values. So for example, your x values might represent numbers of hours that you work at a part-time job, and your y values could represent how much money you make. Well, how much money you make responds to how many hours you work. So that's what we're talking about with constant rate of change. So let's jump into this first example. And it says, what is the constant rate of change shown in the table below? So a table is one way that x, y values can be represented, and we can look at a table and determine the constant rate of change. If you look right here, you'll notice that this says change in y over change in x. That's exactly what constant rate of change is. It's a ratio or a comparison of the change in your y values as they relate to the change in your x values. So we can just start at the beginning of the table and look at the bottom, the money spent, and those are your y values. So if we look at how y changed, it went from $9.25 to $11. Well, that's a change of $1.75. When y did that, x, which is the rides taken, changed from 1 to 2, which is a change of 1. So if someone were to just look at this graph and look at these first XY pairs, you might think that each ride costs $9.25, but we can see now that that's clearly not true. That's because there must have been some one-time price of admission, and then your rides, or maybe the tickets that you purchase for the rides, is in addition to that admission cost. So our first change in Y was $1.75, and X changed by 1 at that same time. The next change in Y went from $11 to $12.75. That's again a change of $1.75. At that same time, X went from 2 to 3, a change of 1. Then Y went from $12.75 to $14.50. That's another change of $1.75. At that same time, X went from 3 to 4, which is a change of 1. And you can see that all of those changes are equal to $1.75 over 1, which means that our constant rate of change is $1.75 per ride. So if you wanted to figure out the cost of admission, you could simply subtract $1.75 from $9.25, because $9.25 was the price with one ride taken. So if you subtracted $1.75 from the $9.25, then you could figure out that initial cost of admission. Let's look at this next one. Ethan paid $16 for 8 sodas plus $5 for a pack of cups. Which equation can be used to find y, the total amount he will pay, given x, the number of sodas he will buy? I think that name is correct on your paper, but it's two different names on mine. So he paid $16 for 8 sodas plus $5 for a pack of cups. And to be careful here, he didn't pay $16 per soda. It was $16 for 8 sodas. So if we do 16 divided by 8, we can see that that is $2 per soda, which means I know that 2x will be somewhere in the equation, and x is going to be your number of sodas. So if it's $2 a soda, you would do 2 times x plus $5 for a pack of cups. So the equation would be C, y equals 2x plus 5. So our constant rate of change here is $2 per soda. Another way to think of constant rate of change is to simply think of it as your unit rate, your cost per one. Remember, unit rate is always per one. You can also see that in an equation like this, in a y equals something times x plus something, in an equation that looks like that, this value next to x, that's your constant rate of change. Okay, next example, write an equation that can be used to find y, the number of eggs, in x dozen. So in this example, we're talking about dozens, and we know that dozen means 12. So if y is going to represent the number of eggs, and x is going to represent dozens, you could think of this in a table form. So x is the number of dozens, so we could think maybe 1 dozen, 2 dozen, 5 dozen, 8 dozen. I'm just making up numbers. It doesn't matter what you put in the x values. So if y is the number of eggs, well, if I have 1 dozen, 1 times 12, I'm going to have 12 eggs. If I have 2 dozen, that's 2 times 12. That's 24 eggs. If I have 5 dozen, that's 5 times 12. That's 60 eggs. And if I have 8 dozen, that's 8 times 12. And that's 96 eggs. So we can see that every single time we are simply multiplying our x value times 12 because we know there are 12 eggs per dozen. And guess what our constant rate of change is? Our constant rate of change would be 12 because our equation would look like this. Y equals 12x. So that's a proportional relationship. In a proportional relationship, it's really easy to see the constant rate of change because it'll be the same as all of your y values divided by x. And that's not the case if it's not proportional, but if it's proportional, you can just take your y values and divide them by their x values. Okay, in this next example, it says a chef made 3 dishes in 45 minutes. Create a table and a graph to represent the situation. So we know 3 dishes in 45 minutes. Now, what if I wanted to know just 1 dish? Because remember, your constant rate of change is just your unit rate. So if I want to know 1 dish, well, let's take 45 minutes and divide it by 3. And I can see that for 1 dish, it'll take 15 minutes. Well, now that I know that, I can figure out any number of dishes. And let's say 5 dishes. Well, that will be 15 minutes times 5. That's going to be 75 minutes. So our constant rate of change here is 15 minutes per dish. Now, if we want to graph that, so here's our x values. That's always your x-axis. And then your vertical one is always your y-axis. So my x-axis is going to represent dishes. So I can have small numbers there. That's fine. So let's say 1 dish, 2 dishes, 3 dishes, 4 dishes, 5 dishes. But now on my y-axis, those are pretty big numbers. So I don't want to just count by ones. In fact, let's go ahead and count by, let's do 20s. So 20, 40, 60, 80. And I look at my table, and I know 1 dish took 15 minutes. So write 1 up 15. 3 dishes was 45 minutes, so write 3 up to 45. 5 dishes was 75 minutes, so write 5 up 75. That right there. And then connect those. And there's my graph. So that table and that graph both represent the exact same thing. And what we have here is 15 minutes per dish. Again, a proportional relationship where you could just take each of your y values and divide them by your partner x value, and that will give you your constant rate of change. Okay, next example, the average change in temperature. This is just another way for asking for a constant rate of change or for the unit rate. So again, constant rate of change is just the change in y over the change in x. So if we look in our table, y went from 1 to 2. At that same time, x went from -10 to -5, so it went up 5. And the next one, y went from 2 to 4, so up 2. And x went from -5 to +5, that's up 10. Then y went from 4 to 7, that's a change of 3. And x went from 5 to 20, that's a change of 15. So at first you might think, well, that's 3 different ratios, so this doesn't have a constant rate of change. However, our second 2 ratios can be simplified. 2 goes into itself once, 2 goes into 10 5 times, that simplifies to 1/5. 3 goes into itself once, 3 goes into 15 5 times, and that simplifies to 1/5. And so we can see that as the hours changed by 1, then the temperature changed by 5. So we can think of that as changing 5 degrees per hour. And that's it for Unit 3, Lesson 7. You now know how to find constant rate of change.